Hello everyone, this is an EMT assignment on Coulomb's law based on the repulsion of two balloons due to electrostatic force. Electric charge is a fundamental property of a matter. All objects are made up of charges. Coulomb's law is defined as a force of one charged object exerted on a second charged object is directly proportional to the charge on each of them and inversely to the square of the distance between them. Coulomb's law has made it possible for us to dive deep into the theory of electromagnetism and discuss the electric charge. As such, this study investigates how we can determine the total charges in an inflated balloon using Coulomb's law. Data was collected by conducting a simple experiment with two balloons and string. With the static electricity of balloons, we can calculate the charges in the balloons manually. However, certain assumptions must be made by neglecting the gravitational force that exists between both balloons and a rough estimate of measurement error. Here is the nomenclature. We'll be using these variables while discussing the theoretical calculations. Balloon excess charges experiment is based on a basic principle called Coulomb's law. The scientist who discovered this law is Charles Augustin de Coulomb and thus named Coulomb's law. Coulomb used the torsion balance to study the repulsion force and force of attraction between two charged particles. He managed to determine that the electrical force between two charged particles is directly proportional to the product of the quantity of charge on certain objects and inversely proportional to the square of their separated distance. This experiment can be explained by using Coulomb's law, in which when the two balloons are rubbed by the other material, the negatively charged particles are more likely to be lost from the material to the balloons. This makes both balloons have the same charge, which are negatively charged. The similar charges will repel each other and thus making both balloons pushing each other. Now let us look at the electrostatic demonstration. Moving a balloon with a Teflon rod. Charge the balloon by rubbing it with a microfiber cloth to leave an excess of negative charge on its surface. Charge the Teflon rod by rubbing it with a microfiber cloth too, which will cause the balloon to repel the rod because they are both negatively charged. This is called electrostatic repulsion. This also happens when two negatively charged balloons are held next to each other. Two uncharged balloons are initially hung next to each other and become charged if they are rubbed with the fiber cloth, the cloth causing them both to repel each other, because like before they both have the same negative charge. The balloons will also repel the Teflon rod as it is negatively charged too. However, when a piece of wood is brought nearby, the balloons are attracted to it because it has a relative positive charge in comparison to the negatively charged balloons. Let us discuss the theoretical calculations. The action of rubbing the balloon surface charges the body itself, producing electrostatic force in the system. From the observation of the experiment, both two balloons repel each other due to the similar charge of the body. To investigate the total charge of each balloon, the free body diagram needs to be drawn as shown. Since there are threads holding the balloons, tension force is existing. Besides, the charged balloons will repel each other since they are charged in the same way, producing outward electrostatic force. To make the derivation of equations easier, the mass of both balloons is assumed as the same and it contributes to the gravitational force. Therefore, the whole free body diagram will be symmetric. The system is assumed as equilibrium because it is in a static condition. Force in the system consists of vertical and horizontal components. Since the tension force Ft is neither vertical nor horizontal, it can be resolved into horizontal tension force Tx and vertical tension force Ty, respected to the angle. Thus, Tx is equal to Ft sin theta, Ty is equal to Ft cos theta. From the previous observations, we get equation 1 from the horizontal components and equation 2 from the vertical components. Now if we substitute equation 2 into equation 1, we get the equation for the magnitude of charge Q. In conclusion, the experiment of balloon excess charges can be explained by using Coulomb's law to prove the forces exerted between electrostatic charges. The action of rubbing the balloon surface charges the body itself, producing electrostatic force in the system. It resulted in the two balloons repelling each other. The mass of both balloons is assumed as the same and it contributes to the gravitational force. To investigate the total charge of each balloon, the free body diagram is drawn and substitutes all the values of each component inside the calculation part. These are the references which we have gone through, which are available at the given links. This brings us to the end of the presentation. That's all. Thank you.